In our previous class, we started a discussion on projectile motion, and we said projectile motion is a motion that occurs under the influence of gravity. And we discussed some examples, some common examples of projectile motion that we can see around us. But for today's class, we are going to discuss some terms associated with projectile motion. And the first one we will consider is the angle of projection. If you consider the figure we have over here, okay, the angle of projection is the angle which the direction of projection makes with the horizontal plane. The horizontal plane shows the displacement or the distance covered, while we can represent it with x and then represent the vertical plane with y. So of course, the angle of projection is the angle which this direction of projection makes with the horizontal, and we can see it to be equal to be this segment over here. Okay, most times we represent it with the symbol theta. Is that okay? So theta is the angle of projection, which is the angle which the direction of projection that can be illustrated with this, the direction of projection makes with the horizontal. Is that okay? Which makes with the horizontal plane through the point of projection. And where exactly is the point of projection? This point over here is the point of projection. So we can say we have something like this. So this is our angle of projection. Is that okay? Now let us consider the next term here, which is the trajectory. Trajectory is actually the path which describes the motion of the particle. And we said the particle started from this point and then continued till it gets to this point and then falls down to the horizontal plane. So this path described by this particle is called the trajectory. Is that okay? So the next thing we will consider is the time of flight. And the time of flight is simply the time required for the projectile to reach the maximum height and then return to the plane of projection. This is the plane of projection. So the time it took the projectile, that is the body that is being shot, the body that is being projected, to reach the maximum height. Where is the maximum height? Of course, this height is the maximum height. Okay, so the time it took to reach the maximum height and the maximum height is described by this horizontal dotted line. Okay, so from here to this place over here is the maximum height of the projection. So the time required for this body over here to move to this point and then come back to the point of projection is called the time of flight. And this time of flight can also be described as the time taken to cover the range. But the question is, what then is the range? Range is the maximum horizontal distance covered by the projectile from the point of projection to where it hits the horizontal plane. And it can be described by these paths over here. We said it is the maximum horizontal distance covered by the particle or by the projectile from the point, this is the point where it is being projected, to where it hits the horizontal plane. So the time taken for the particle to move through this trajectory and then come down to the point of projection or to the horizontal plane is called the range. Is that okay? It is the maximum horizontal distance by the projection from the point where it is projected, which is this point. Let us call this point A, to from the point of projection A to where it hits the horizontal distance. Let us call this horizontal plane rather. Let us call this point B. So this is actually the range of the projectile. And then we can I already pointed out what the maximum height is while discussing the trajectory, okay, and the time of flight. So the maximum height is the highest vertical distance attained, and it is this point over here. We have different vertical distances. This is a vertical distance. This is a vertical distance. This is also a vertical distance. All these are vertical distances, but the highest of them all is the maximum height, and this is what we have over here. Is that okay? So this is just the diagrammatical representation or illustrations of all the terms that are associated to projectile motions. So this is where we draw the curtain for today's class. I'm sure you have a better understanding of what all these terms are. In our next class, we will give the mathematical expressions for each of these terms so that we would know how to apply them whenever we see problems under or relating to projectile motions.